Hello there, welcome to a new presentation. Well, in the previous session I talked about the straightening rock samples, and we realized that how chemical resins can make the specimen better by improving the mechanical characteristics. Today I'm going to talk about the stone slabs, which have more and more usage in stone industry and also in buildings. I will make a brief mention about how slabs get from blocks, or from which stones we can get slabs, and after that, like the previous session, I will continue the subject by using an article. Well, as you can see on the slide, a stone slab is a big stone, flat and relatively thin, often of rectangular or almost rectangular form. They are generally used for paving floors, for covering walls, or as headstones. The stone slabs can have different sources. They could be metamorphic, like marble. It could be sedimentary, like travertine, and it could be an igneous rock, like granite. And because of different sources, the slabs have different colors with different mechanical and chemical characteristics. To make it short, preparing stone slabs have 3 stages: excavating rock block from mine, transport the rock blocks to the processing stage, and at the end, cut the blocks into slab size. The standard thickness of slabs is 2 cm, and for normal projects the length is 220 cm. For exporting, it could be 280 cm too. Well, to make it clear, here is a short video of how a rock block cut per wires. The wires should be made of diamonds, the segments also, to cut the block better, and the water flow down for cooling the segments and also for preventing spreading the cutted block. As you can see on the video, each cutting machine has its own time of processing, and also the time related to the rock block that we choose to get a slab from. After getting the slabs should go to processing stage, I mean the epoxy and polishing. Well, for better sense, here is an article by Brazilian researchers. The application of castor oil based polyurethane resin in the dimensional stone block wrapping process. They use both bio-based and chemical resin for straightening 2 different types of rock slabs, one quartzite type and the other the marble type. And at the end of their project, they realized that each resin has its own effect on the mechanical characteristics of the slabs mentioned. The epoxy resin used in this process comes from a non-renewable resource and contains toxic substances on its composition. Therefore, in order to increase the eco-efficiency in the sector of dimensional stones, the comparison of epoxy resin with an ecological and non-toxic resin based on the castor oil was carried out, aiming to know the resulting tensile strength in the contact of polymer with the stone surface. 2 types of rocks were tested, a silicate and carbonated one. The results indicate that the castor oil resin performed a higher tensile strength regarding carbonate rocks, suggesting that the castor oil resin could replace the epoxy resin when applied to this rock group, providing an environmental advantage and a global marketing differential. Well, as I talked about, the goal of this research is straightening 2 types of rocks with 2 different resins. The bio-based one, I mean the castor oil resin, and the chemical one, the epoxy resin, on 2 types of rocks, I mean one quartzite and the other one of the marble types. Well, here is the chemical compound of resins. As you can see, the epoxy resin is a final product of reaction between epichlorohydrin and bisphenol A, and the castor oil resin is get from the reaction between the isocyanate and the polyol. For this research, the sown samples were cleaned before to receive the resin application. The preparation of the resins was made according to the manufacturer's recommendation. The procedure of the castor oil polyurethane resin recommended to the blend the two components of the preparation of 1 volume of polyol to 1.2 volume of polymer. For the epoxy resin, the recommendation was to blend 1 volume of mixture of 0.3 volume of enduring. Subsequently, they were applied on the surface of the sown samples. There was a period of 48 hours for curing process take place completely before testing. Well, as you can see on the slide, the circular holes were made on a stone surface with approximately 50 mm in diameter and 5 mm in depth. The hole were spaced about 60 mm. Then the surface of the specimen were again cleaned and dried, and the bonding process was performed using a specific glue indicated by the adopted ASTM standard. After the solo test, the tensile strength test was applied. Finally, here is the final qualitative picture after resin process. In comparison to epoxy, castor oil has better function on marble, and in the case of quartzite, the epoxy resin show better results. Well, as you can see on the chart, we had 12 samples of two mentioned slabs. The results indicate that the castor oil has better function on marble samples, and the chosen epoxy resin has better behavior on quartzite. In addition to tensile strength determined in this study, it was found that the mineralogy has important influence in test results. The castor oil resin showed better behavior than the epoxy resin when applied in the carbonated stone. However, the result of tensile strength for the silicate material was higher for the epoxy resin. It indicates that it is still necessary further investigation on the stone mineralogy and other parameters such as porosity, the alteration degree that could influence the resin adhesiveness, and the performance of this technique. Well, let me finish this presentation. I hope to be useful for you. Have a good time.